need a mind shift to reconnect world development to planet Earth. And we need to start recognizing that we're now in a dynamic, transformative, nonlinear, exponential phase where the key challenge is to start seeing the opportunities in transformations to global sustainability. We have overwhelming scientific evidence that humanity now face a new juncture of grand global risk. We have actually just in 5 decades transitioned from being a relatively small world on a big planet where we could allow ourselves to have unsustainable economic growth without Earth sending any invoices back to humanity, to now being, with overwhelming scientific evidence, a big world on a small planet. We've reached the saturation point and we're hitting the ceiling of the biophysical capacity where we can no longer exclude destabilizing the entire Earth system. And this illustration is so powerful, just reminding us that we depend on this 11-kilometer thick atmosphere for our survival on planet Earth and the stability of an Earth system that remains in its Holocene interglacial state. It actually means that incremental, linear, business as usual is no longer an option. We've had 5 decades of negative exponential rise. Now the challenge is to tip over into the similar exponential journey towards a transformation to sustainability. And I think it's good just to kind of remind ourselves what this means. If I take 35 linear steps from where I'm standing, I will barely reach the coffee stand outside of this room. But what happens if I take 35 exponential steps? If I double at each time step? Well, what happens is not much happens in the first 20 or so steps. I would reach kind of Copenhagen after 21 steps. But 3 more steps, oops, I'm in New York. Another 2 steps, and I've circled the entire planet Earth. And if I add another 9 steps to my 35, I reach planet Mars. That is what happens when innovation starts doubling at every time step. And that's exactly that surf point that we're starting to see indications of, which could actually take us to a point where we avoid the grand global risks and choose a journey towards opportunities. Now, science is getting nervous. Seriously nervous, because we're starting to see destabilization of critical biomes that regulates the stability of the entire Earth system. You've all certainly followed what we heard just a few months back with the anomaly of a 20 degrees Celsius deviation of warming in the Arctic, which is something that was doubly worrying for science. One was, it was beyond the predictions. It was well outside what could be predicted in variability plus global environmental change. But also, and you see here the natural curves through the seasons of how the Arctic sea ice normally distributes itself. You see the lowest curve right here is the dramatic year 2012, which was a very nervous point. Actually, the entire Greenland ice sheet was a liquid surface which absorbed so much heat, it actually exceeded in terms of absorption of energy, because a white surface reflects back energy to space, meaning that our polar regions are cooling systems for the entire Earth system. But 2012, during 2 weeks, just the absorption of heat, because the entire Greenland ice sheet was a liquid, exceeded the annual energy consumption in the United States. Just talk of feedbacks when the Earth system starts really moving in the wrong direction. This deviation in October, November was something we'd never seen before. The ice was not reestablished as it should in winter. But the real nervousness in science was that this was, in one way, a surprise because it could not be predicted, but it was even more worrisome because we understand what's happening. We understand that it is the upwelling of an unprecedentedly warm ocean that takes up 96% of the heat caused by our emission of greenhouse gases. Talk of a resilient Earth system. We emit greenhouse gases for 150 years, and 95% of our debt is absorbed and hid under the carpet in the oceans, and it's now upwelling in the Arctic. We also know that the Arctic vortex that keeps the high-pressure cold air and the jet stream stable was opening up in a very wiggling way, releasing heat to southern latitudes and letting heat into the Arctic. Combine that with atmospheric warming, which, as you may recall, a 2-degree warming in the world means 5-degree warming in the Arctic. These things together led to this surprise, exponential early warning for humanity. These are the kind of destabilizations we're seeing across the world. But I can tell you, science gets even more worried when understanding what we depend on. So we have big changes occurring, but we now understand scientifically what's the state of the planet that we depend on to be successful as a world community. This comes from ice core data, and I think that this is the most important graph we have today. Because this is not the last 1 million years of us going in and out of ice ages in our 100,000-year Milankovitch cycle. No, this is the last 100,000 years. Why is this exciting? Well, because we have been modern humans on Earth for roughly 80,000 years. So we've had the same intellectual and physical capacity to develop civilizations as we know them today. During this period, the y-axis here is temperature variability, this is from the northern hemisphere, was, I can tell you, a jumpy ride indeed. You know, we were hunters and gatherers, we were a few million people, we were jumping between plus minus 10 degrees Celsius in a decade. We had a very rough time until we exit the last ice age and enter this last orange period you see here, which is this extraordinary, in Pope Francis' words, miraculously stable, interglacial geological epoch we all learned in school to call the Holocene. It is so stable, in fact, that the maximum temperature variability on Earth is plus minus 1 degree Celsius. 1 degree Celsius. And we barely enter the Holocene, and we do our most important invention of all. We go from hunters and gatherers to become farmers, and off we go in the civilizational journey as we know it. And this is, we know today, the most dramatic and simple message science has to humanity. The Holocene is the only state of planet Earth, the only equilibrium state we know that can support our modern world. And this may sound very dramatic, but the good news is that we know the Holocene so well, so we can actually put very high scientific criteria of what it takes to remain in the Holocene. But dear friends, we're moving out of the Holocene. We have a journey which is taking us to a new geological epoch. And this journey starts in 1750 with the Industrial Revolution. It starts with James Watt inventing the coal-fired steam engine in the United Kingdom. It is the takeoff point of the Industrial Revolution. It's a point that occurs with industrialization, railway, infrastructure, and we rapidly colonize the entire planet. But we're still just having very incremental impacts on the Earth system. On the y-axis here, you have our impacts on carbon dioxide, biodiversity, sulfur emissions, overfishing, all the parameters you may think of. We come to the end of the 19th century here, and Fleming invents penicillin, which creates longevity, and we go from 1 billion towards the population growth we know. We come to 1900 here, and the Haber-Bosch process is invented, allowing ourselves to produce modern food that can actually feed a much larger population. But we're still at this linear phase until we come to the 1955 branch point. And that is, dear friends, when science today stipulates that this is when we enter the moment of the great acceleration. We're 3 billion people, 10 years after the Second World War, and off we go in an exponential rise of our pressures on the Earth system. We start overusing biodiversity, deforesting, emptying oceans to 60% today. We have emission of greenhouse gases that just concentrates more and more. We see Arctic ice sea loss. The warnings come already in 1962 with Rachel Carson's famous Silent Spring, warning us that if we continue in this way, we cannot exclude negative impacts for humanity. The Club of Rome comes 72, warning that by 2020, 2030, we could go in the wrong direction. The warnings came early, but we continue on the exponential journey. And it is in 1990 that we start seeing the first evidence of invoices being sent back. So it seems like our unsustainable journey worked up until the late 1980s. But the collapse of cod fisheries out of Newfoundland, we crossed 350 ppm in carbon dioxide concentrations. We see accelerated ice melt. We see the first signs of large-scale acidification and bleaching events in coral reefs. So it is in the last 2-3 decades when we've reached the saturation point. And today, we have overwhelming evidence that these myriad of hockey sticks results in us being able, scientifically, to welcome humanity to the Anthropocene. We are in a new geological epoch. We are now the dominating force of change on planet Earth. We exceed the forces of the sun or of volcanic eruptions. We are in the driving seat. In fact, the big question then is, well, if we're punching the Earth so hard, what's the response? Well, as long as the Earth system is resilient, the response is linear, and so it was up until 1990. But today, what you see on this map is the scientific evidence of the tipping points that we can induce in the Anthropocene in the saturation state. We now have ample evidence that Earth is not responding linearly. Long periods of incremental change as long as oceans and forests and the climate is strong, can be incremental. But then as we weaken the system, suddenly a small incremental change can lead to abrupt, irreversible, and potentially disastrous shifts. Here we have the latest map of the different tipping points we can foresee. The key here is it's not only the risk of destabilizing the Greenland ice sheet or the West Antarctic ice shelf, it's also the risk of tipping over the Amazon rainforest to savannas. It's the risk of losing the monsoon rainfall systems because of destabilizing the interconnectivity between the different components of the Earth system. To put it simple, we all depend, irrespective of where we live, in what economy or what business we depend on the functioning of every biome on planet Earth to avoid tipping points that could take us in the wrong direction. And now we can actually scientifically even couple this between the Paris Agreement and tipping points. And this is the first time this is done. I think this has a very powerful message to us. So what you see here is the last 20,000 years of the 100,000 cycle I showed you earlier. We exit the last ice age right here, 20,000 years ago. You see it's minus 3 degrees Celsius on Earth. Just a few degrees lower is an ice age. We come out of the last glacial, then we enter this extraordinarily stable Holocene period. And then here we are today, starting to warm the planet. What you see here is the Paris Agreement. It is about staying under 2 degrees Celsius warming compared to the pre-industrial level, aiming for 1.5 degrees. What you see is that even if we succeed with Paris, it's above the maximum range for the Holocene. So it's already kind of a little bit of a nervous point. This is the IPCC scenarios, and you know that as business as usual, we're heading towards 4 degrees Celsius average global temperature by the end of this century, a point we haven't been in for the past 4 million years. But here comes the key message. This is when you overlay the risk of tipping points. And what you see here in the bars in red is the uncertainty range in science. And then you see the different systems at what temperature we may induce tipping points. And I'll just kind of focus in on this range of systems that actually are within the Paris Agreement. So what you see here is that even if we deliver on Paris, we cannot exclude losing the coral reefs on planet Earth. And we saw evidence last year with the remarkable El Niño event of a 90% bleaching even in the Australian Barrier Reef, which was totally saved in the 1998 El Niño event. You see what is at risk at the Arctic sea ice. We cannot exclude losing the system even at 2 degrees Celsius. And even the West Antarctic ice shelf and Greenland are in that risk zone. And the key point here, dear friends, is that it's not as if we lose it, it's gone. No, the key point is that we may push on buttons that would irreversibly commit us to lose the systems. It might be 1 century, it might be 3 centuries, but we cannot do anything about it. Earth goes from a friend to a foe and takes over. And that is why it's so important for exponential transitions. We must now understand that we are this fundamental force of change on planet Earth. It's so fundamental, in fact, that here I'm just sharing with you ongoing research on what I would argue is the most fundamental science question we're facing today. Over the last 50 years, we've actually exponentially moved in the wrong direction, exceeding where we've been for the past 10,000 years. But equally, we now know with very high degree of evidence that what we do over the next 50 years will determine our outcome for the next 10,000 years. So we are the generation right at that tipping point. We were alive in the exponential journey that took us here. We will probably be alive in the journey that will decide the outcome for the next 10,000 years. Because we know that the planet Earth can be in 3 types of equilibrium states. It can either take the cycle of glacial cycles, the 100,000 year cycle when we go into deep ice age. Temperatures go down, which means that the planet becomes whiter, reflects more heat into space, and gets self-reinforcing into an ice age. So that's critical, that feedbacks takes us into these big cycle. And then we have the little cycle here, which is the interglacial cycle, the cycle that has enabled us to thrive on planet Earth, the cycle that stays in the interglacial that has 2 caps of ice, keeping the temperature at this plus minus 1 degree Celsius. We're now trying to explore what's the ultimate planetary boundary level beyond which we risk going into the 3rd state, the only 3rd state we know, which is the hot state, that we would irreversibly push planet Earth to self-reinforced warming to an ice-free state. And unfortunately, we have so much evidence of the carbon dioxide and the heat in the oceans, of the carbon dioxide in biomass and soils, the methane in permafrost, the ice and its albedo effects, that we have the machinery for great change that could take us in the wrong direction. This, in my mind, is the biggest challenge we have, to stay in a manageable interglacial and to define, therefore, planetary boundaries. And science has done this to ask the question, what are the processes that determine the stability of the Earth system? And what can we scientifically define as boundaries within which we have a safe operating space, shown in green here, that allow us to remain in a manageable Holocene-like interglacial, to do the exponential journey in the right direction. This gives us a very interesting journey over time, because we started here with James Watt in the Industrial Revolution, being right at the center of the safe operating space. But already in the 1950s, we started off in the Great Acceleration. You see that we already at that point were kicking off the dangerous drive to the sixth mass extinction of biodiversity loss. In the 1970s, we're filling up very prominently the whole safe operating space. We're booming out on nitrogen and phosphorus, on the ozone depletion of the stratospheric protective ozone layer, and on biodiversity. And then look at the situation today. We are at this grand risk zone, but there is one success story. We were at a danger zone on stratosphere, but science identified the depletion of the stratospheric ozone layer, and policy listened, business has solutions, and we were able to transition back into a safe operating space on a stable stratospheric ozone layer. So we have been planetary stewards once before, and now is the time to become planetary stewards at the planetary scale entirely. And we have the agenda for this. We have the 17 Sustainable Development Goals. These are a roadmap for the first time for people and planet. I would just argue scientifically that if you take the science that we have today, that let's not allow ourselves to use these as a Swedish smorgasbord and kind of cherry pick our favorite goals. Let's now recognize once and for all that they should be organized as a wedding cake. It is truly so that goals 6, 13, 14, 15, the planetary boundaries on water, oceans, biodiversity, and climate, are non-negotiable. They give us the safe operating space to be successful for thriving humanity on social and economic development. So there is reason to be very proud of a science-based agreement in Paris, of transitioning to a future under 2 degrees Celsius, but it requires a deep transformation. And to close this, just to give you what this really means in exponential change. This is where we are in terms of global emission of greenhouse gases. It's roughly 40 gigatons, billion tons of carbon dioxide, and this is where we have to be. We need to transition into a fossil fuel-free economy by mid-century and go to negative emissions to stand a chance to deliver on Paris. Now, this can take us into a few key messages. The first one is this one, that we need to peak emissions of greenhouse gases no later than 2020. In 3 years' time, we need to veer off into a journey that then must take us to a net zero carbon economy by mid-century. This is a revolution. This is an exponential journey, no doubt. The second key message is that we need to be at zero by 2050, including land use and agriculture, which requires a massive transformation in sustainable agriculture. Actually, to a point where land use and forestry must be negative emissions over the next half of this century. So sustainable agriculture and forestry is a fundamental prerequisite to succeed. As if this was not enough, we also need to invest in engineering, carbon capture and storage at a massive scale to have a chance to stay under 2 degrees and reach 1.5 degrees Celsius. And finally, we need to maintain the negative carbon sinks. The fact that 50% of our emission greenhouse gases are taken up in oceans and in ecosystems, and that resilience must be kept. So this is the story that we need to take on, and it is an exponential story of massive exponential change. This leads to the conclusion that we need a carbon law, an exponential law equivalent to the Moore's law, as you remember, of computer chips doubling in speed every 18 months. There is actually an equivalent science-based carbon law. And that carbon law says the following. If every one of these oil barrels is 10 gigatons, we today emit 4 of them, 40 gigatons. And the carbon law is to halve emissions every decade, meaning that going from 40 to 20 in 10 years, from 20 to 10 in 10 years, and from 10 to 5 in 10 years, and then in 2050 have negative emissions, so we are at zero from land use. This carbon law can be applied by any business, any country, any household, and the world as a whole. Half your emissions every decade, we are within a Paris Agreement. Are we actually at a point where we can succeed? Well, potentially yes. This is a very exciting first evidence of the fact that we seem to be starting to bend the curve of emissions already today. The last 3 years, we're starting to see a leveling off of global emissions because the 40 nations reducing emissions outpace the majority of nations that are increasing emissions. We may be pushing ourselves in the right direction. This is another good evidence showing that the pace of renewable energy is actually doubling every 5.4 years. If this exponential journey would continue, we would by 2040 have 100% of our primary energy from renewable energy. If we double every 5.4 years, as we're doing today. And we have evidence that this is happening. On wind and solar and battery capacity, we are actually at an exponential reduction in cost, exponential rise in uptake. We are at the early stage, the first 21 steps, the Copenhagen steps of an exponential journey. What if this continues? What if we are able to meet the SDGs by 2030 and then go multiple pathways to a future where we thrive within planetary boundaries on our small, small planet with this thin layer, but it's our best friend and still the window is open to succeed. Let's hope we do so. Thank you very much.